Hello. Hi. So, this is where we start the actual reason for creating this channel, the actual reason for helping you guys. This is where we start the database designing process. Now, anywhere you go, any place that you go, any online video, any online lecture, any online blog, you will see these two examples, right? How a database that is like this can become like this. And that's the goal of designing a database. But why should we design a database? To reduce overhead, let's say, right? If you have created classes before, okay, I know everyone codes, right? If you have created classes before and you forgot to add some property in the class, and how adding it later on affects everything that you do, everything that you create, every place that you have made. Let's say you are adding to a new property to the constructor, how it changes every place that you need to change. And it's such a hard thing to make it work. After that, there's so much rework. That's why a database design is very important, because as code works, code is kind of simple to work with in that sense, okay? But a database design, dude, that is hard, like really hard. Okay, if you create a table and later on you're saying, okay, I want to add a column or remove a column or alter one column, the data type or the length of it or something, it's going to take a lot of rework. Because as code does, you can have tools, you can have different libraries from which you can just make the change in one place, and that can happen in all the places, like control that r plus r thing in Visual Studio, right? But for database, no, bro. You have to go to everything that you're doing. In many places, in many cases, people always create people don't alter the existing table. They create a new table, they create a new relation, and then they work upon it. In many places, people drop the whole database and create something new, and then they copy the table data with everything like null or default values like that. And that's a very big headache for anyone out there. So today, today and from here on, we'll be trying to learn how to create databases, how to create good designs, how to understand how to create them with all the concepts that we have seen before, like normalization, relationships, like cardinalities, or functional dependencies, keys, etc. Everything that we have seen before will help us to create something like this, something that makes sense, something that is important for you to make something good, something better, something where you can scale it up, something that you can use it for all the structure that you need to have in your code. And for that, database design is very important. It's important for your work, it's important for your examination, it's important for your career, it's important if you want to be a full stack developer, if it's important if you want to be a data analyst. As we are moving to a place in the world where data is so important, with LLMs working all most of the things in the world, right? A lot of people are using those things. But if you don't know how to create one, to understand how one does one work, there's no point of yours existence, literally. How big data is coming in, how data bricks is a thing now, how SQL or cloud DBs are so important now, how these things are used in every solution out there. People are moving towards it because they want to handle big data, they want to create their own LLMs, they want to have a monopoly on that thing in their own market. For that to happen, you need to understand how database design works, and I'm here to help you with that. Now, there's some points. Let's say I will just tell you the advantages and what are the steps or what are the things involved in database design. Advantages, we all know: reduce the redundancy, right? Avoids redundancy. Let's say through normalization, we have that. Data integrity. Now, if you have a structured thing, you with relations and rules and constraints, right? That will help your data to be secure. That will help your data to be correct. So you know that you can trust that data, that you can make the right decisions through that data with your analysis, with your understanding. Scalability, obviously, because we have a relations, right? You can always make a new relation and scale the data. You can always make a new relation and scale the data, and that's what's important, right? To be able to extend it without changing the original one, the open close principle from the solid one, that also applies here. You can understand in that some way. Okay, then simplifies query, that's all right. So we can do joins and selects and blah blah blah, whatever. We are not here to do queries, okay? If we go into that, that's a very big topic, that's a very different topic. You can learn it from anywhere you want to learn. It's always everywhere, throughout the websites, throughout the YouTube infrastructure. There are channels who will tell you how to do queries, and that's very normal. You can learn them, and they're amazing. You can optimize, you can pivot, you can use constraints, you can use joins, you can use this thing, unions and intersections and everything, and to create and optimize your queries and getting the data. Now, what is involved in a database design? There are three levels of database design. The first, conceptual, which is a ERD, that is the entity relationship diagram, where we will make something like this with using two methods. You can always use this one, or there's a second method where you can use this thing where you can explicitly see the attributes. Also, you can point them out as well. In this one is like a class diagram, and this one is a full-blown ER diagram. I learned this in my first year, so I'll be looking at this later on. Many people might not use this at all. They would prefer you using this is like a class diagram, because you have a box. On top of it will be the table name, and below it will be the attributes listed down like this, instead of this thing over here. But still, some people use it. You can see it on the internet, and it will be helpful to you to understand many other things, how a parameter is multi-valued, how it is a foreign key, how it is a key value, how this relationship is different, how this relationship is different, and something like that. You will see, we'll see together actually. Now, logical database design is simply the idea of tables and keys. How you're designing them, how you're making them, that's your structure. That's your queries to create the tables, create those things, right? Physical database design is again an important aspect when it comes to scaling, because you have to understand how it works with your memory, right? If you want to scale later on, how will you scale it? How will you have enough memory? How do you have enough computing power to work with the database that you have? Should you shift to cloud or not? We'll see them one by one. And in the next video, we will start with conceptual design. We will see how the class diagram looks. We'll see later on, we'll see how the ER diagram looks, the full-blown one. And then we will have some different things going on. And we will focus on designing a database and good solutions for, you can say for your customers, if you like, if that's what your goal is, or you can do it for yourself. You can do it for your own company. You can do it for your own thing, and however it works, it doesn't really matter, right? The idea is to create good solutions, that's all. Thank you for watching the video. That's all for today, and in the next one we will start something good and something new. Take care, goodbye, and if you have any questions, just let me know.